Let's start the lecture for today. We want to look at decision analysis. Decision analysis. Already, some of you are doing very well in the eye. So that is commendable if you are part of it. And you know you did well, you are really doing well. So keep it up. We want to look at decision analysis. We make decisions every day, but many people don't use methodologies structured methodologies to decide. And the essence of the lecture today is to show you what structured methodology we should use for decision analysis. The methodology has to be understandable, manageable, broken down into parts so that it can arrive at a conclusion that makes sense. During the time of the linear programming, we were making decisions under certainty. And therefore, everything about linear programming, integer programming, and everything related to maximization and minimization, everything was deterministic, meaning that you had a variable, you know you're going to get an x1, you know you're going to get an x2, but it was a matter of what number of x1. But we also have decision-making under uncertainty, and that is not deterministic, but probabilistic. And this is the focus of today. Before you can understand this topic, there are three things you need to know. The first one is known as DI. Please write it down. The second one is known as SI. Write it down. And the last one is known as PI. Actually, it's PIJ. So the SI is SJ. So you have DI, SJ, and then PIJ. Let's try to understand these three things as we begin our journey. You want to make a decision whether to buy a stadium, whether to build a bank, or to build a university. You don't know which one to go for. And you need an advice. That advice will be made based on some concrete numbers. The decision alternative is the DI. The decision alternative is the individual alternative decisions that the decision maker has to make. So in the example I just gave, what are the decision alternatives? Help me out here. In the example I just gave, what are the decision alternatives? Yasin.
Whether to build a stadium.
Yeah. I mean, there were a number of decision alternatives I gave, so I want to know, what are they?
I honestly heard just the stadium. I don't know if it was my network, but
Okay, no problem. Somebody will help you. What are
and
the
Doc, please, are you
decision?
okay? Because it's like you sound very dull today.
I'm not
Or you're
okay.
tired. Oh, sorry.
So try and then answer my questions. That will ginger me to talk. As you are participating more, it will elevate my consciousness. So I mentioned three different decision alternatives. What are they? Anybody? Michael Quay.
Whether to build a university.
The moment you use the word weather, it means you have other ones, isn't it? You have other ones, but you've only mentioned one because the weather was end with or and or. Looks like none of
Yeah,
you heard about anything.
yeah.
Yes, me.
Oh, sorry.
Yes, sir. So it was about whether to build a university, a bank, or a stadium.
So, Mayor, you were there all this while you didn't raise your hand. Is that it?
Sorry, I thought they could answer that. That's why.
You thought people will answer that. Never
No, I
think.
mean those who raised their hand. I thought they were.
You're also one of those who could raise your hand because I have
Sorry,
to
sir.
repeat it before you say it. So, the decision alternatives are a stadium, building a stadium, building a bank, building a university. So that's what we mean by decision alternatives. You can number them. You can number them as D1, D2, D3, D4. That is what we mean by the decision alternative, the items you really want to decide on. The second thing is the SJ. The SJ is the state of nature. The decision alternative must be chosen based on a certain state of nature. Now, take note that the state of nature is outside the control of the manager or the decision maker. But then the decision alternative is within the control of the decision maker. The state of nature are usually environmental, macroeconomic, and non-macroeconomic factors that can make the decision possible or impossible to undertake. For example, there could be a war, a higher level of a war, a medium level of a war, or a lower level of a war that can affect the decision to be taken. There could be something like a macroeconomic indicator like high level of GDP, moderate level of GDP, low level of GDP, which the decision maker cannot control. So the SJ is a state of nature. Who can give me another example of the state of nature? So the state of nature are always in column. That's why we have something like S1, S2, S3, S4, S5. All of these are the state of nature, usually at the column level. So give me one example of a state of nature aside the ones I've given. Yasin.
Inflation, high inflation.
Inflation. What else? What else? It can be macroeconomic or non-macroeconomic. That's a state of nature. Yes, Yasin.
Political instability, maybe due to election year.
Exactly. Belinda.
High unemployment.
Okay, the level of unemployment. Exactly. So that is it. Now, the final one is the payoff. The PIJ is the payoff. Now, when you can see the way I've written the PIJ, you can see that it's taking the I from the decision alternative and it's taking the J from the state of nature. So the PIJ is normally the outcome, the return, the gain, the loss, the profit, the revenue, the net benefit, all the things that will be the outcome of the decision you have taken. So you can have P11, which is the decision alternative, the profit from decision alternative 1 under state of nature 1. You can have P12, which is the profit from decision alternative 1 and the state of nature 2. You can have P13. The profit from the decision alternative 1 and the state of nature 3. P14. P15. I'm sure you get a picture now. And you can also have P41 here, which is a profit from decision alternative 4 under the state of nature 1. So these are the returns, the gains or losses from each decision. Guys, if you can understand what I've just done in the past 5 minutes, I promise you that 80% of the work is done. So if you don't understand this very one I've done, it's time to raise your hand and then you get explanation. Yes, I see.
Please, initially when you mentioned PID, you said it stands for pay something. I didn't get that. Payoff.
The payoff, which can be profit or loss, is a gain, the outcome of the decision. Okay, we are going to take an example, if you understand. In the example we are going to take, we are going to use 6 different methods to arrive at a decision. That's the whole idea. 6 different methods. So let's take a typical example and then go through each one of this. Now, the methods, some of the methods you're going to see are maximax, maximin, minimax regret, maximax, maximin, minimax regret, equal likelihood, and all of that. But the ones we are going to focus on are the bolden ones. Kofi Wayo wants to invest among apartment, office building, or a warehouse. So you can see that Kofi Wayo has a choice to put in money into apartment building, office building, and warehouse. Normally, if I should ask each one of you, which one would you put your money in? I'm sure everybody will have a reason why he would choose one of them. Kofi Wayo has a choice. But all of these are happening under different states of nature. So when you look at the state of nature 1, the economic condition is up. That is a S1. So you see the arrow going up. State of nature 2, the economic condition is down. So when the economy is good, what will be the returns in investing in office relative to apartment? And if the economy is down, what will be the return in investing in warehouse relative to apartment? So those are the options that we have. Let's look at them. So here you are. And normally you are given this kind of data, or you yourself will read the story and create your own data. So if Kofi Wayo should go for apartment, and the economic condition happens to be good, he will get $50,000. But if the economic condition is poor, he will get $30,000. If Kofi goes for office building and the economic condition is good, he will get $100,000. But if it is poor, he will get negative $40,000. If he goes for warehouse and the economic condition happens to be good, he will get $30,000. But if it is bad, $10,000. So these are the different decision alternatives in the different state of nature and profit or payoffs. Question is, which one will Kofi Wayo go for? There are different criteria for analyzing this. The first approach you're going to use is known as maximax. You may write it down and follow me along. Maximax is for a person, an optimist. An optimist. Who is an optimist? When we say someone is an optimist. Who is an optimist? Justin.
Someone that tries to hope for the best.
Good. So for such a person, which kind of state of nature do you think the person would take, Yasin?
The person will go for the good economic conditions because they believe that things will be.
Good. So under the maximus, write for your notes, best of the best. So such people go for the best of the best. The last best is the state of nature. So the last best is the state of nature. And the first best is a decision alternative. So such a person will first select the best state of nature because they hope for the best. And then after selecting the best state of nature, he will look through and select the best decision. So who can raise a hand and tell me which will be the decision alternative that this person will take? D1, D2, D3. Which one of these will the person adopting the Maximax approach select? Deborah.
D2, the office building,
Why?
because it's the option under the good economic conditions and is the highest in that category.
Perfect. Excellent. Done. That's the first criteria. Easy peasy. The second approach is known as the maximum. Maximum. The maximum uses something known as the best of the West. The best of the West. Such a person is a pessimist and goes for the best of the West. Who is a pessimist here? Who is a pessimist from your perspective? Who is someone we call a pessimist? Gordon.
Someone who anticipates bad stuff.
So that person will go for what state of nature? Gordon.
The last one, warehouse.
Now, what I mean is
no,
that person will go for what state of nature? I didn't say what decision alternative.
A poor condition.
Condition. Let's start there. So the worst in the sentence here means that the person will first select the worst state of nature. That's what the person will pick first. Now that he knows that he has taken the worst state of nature, that person will now select the best out of that worst state of nature. The person will now select, that's why we call it best of the West. The person will now take the best out of the worst state of nature. So, which decision are you going to select based on this conservative approach? It is also sometimes called conservative approach. Ajay.
Apartment building,
Why?
because the worst condition is the poor economic conditions, and the best among them is the $30,000.
Perfect. There's no problem with that. So that is a second approach. Yeah, it's like we are learning and learning and not learning. This is actually learning. The third approach is what is known as the minimax regret approach. The minimax regret approach. I wish you are making notes equally. Because if you are, and I wish you've drawn the table by now. So please draw the table, remove the 1,000 at the end of each value so that it becomes easier to mention. Because very soon I'll move away from this, and then you might be saying that, can we please see the table? I want you to write the table. Use the D1 and then the S1 and S2 is enough. And the rest becomes the numbers, the pairs. The minimax regret. Now let me ask you, if the decision or maker had actually selected the good economic condition, the first choice, using the maximax, if that person has selected a good economic condition with the intention of choosing the office building, with the intention of getting the 100,000, but the economic condition turned out to be poor, how would that person feel? Anybody? How would that person feel if it had turned out to be poor? Yasin?
They'll have a lot of regrets in thinking what if they had gone for another decision alternative.
Very good. He will feel something we call regret. There's no doubt he's going to feel regret. But what do you think this person would do? Would he like to have the lowest regret, or he would like to have the highest regret if that should happen? Would a person, of course, you know that this thing, there could be situations, but would you be careful in such a way that you don't want to have a lower regret or a higher regret? Which one is this person going to hope for? That even if I regret, I should have what kind of regret? Is it higher, lower, or medium? I see.
Lower regret.
Good. So, suppose this person had chosen the 100,000, okay, and then the economic condition had turned out to be poor. Then, if he wants to reduce, and now we are here, okay, we are in the poor state here. If he wants to reduce his regret, as you are all saying, that would have wanted the lowest regret, which one of these poor situations would he have to choose for the regret to be lower? Because the 100,000 is gone already. But if he had done it, which of these three on the poor side would he have to choose for the regret to be lower? Anybody? We are getting deep here. Yes, sir.
30,000.
You would have chosen 30,000 so that the actual regret value would have been what?
Will now be 10,000 loss.
Now, the actual regret value, if he now chooses the 30,000, since the 100,000, now you got to juxtapose the 100,000 and the 30,000. What will now be the value of the regret now?
70,000.
70,000. If he had chosen the warehouse under the poor economic condition, Laurentia, what would have been the regret?
So if he had chosen the warehouse under the poor economic condition, it would have been 90,000.
And if he had chosen the office building?
If he had chosen the office building under the poor economic condition, that would have been 140,000.
Yes, 140,000. So the regret would have increased more, but the least regret he will get will be the 70,000. Now that is important. That statement is important. So this guy would like to reduce his regret as possible. So such a person using the minimalist regret approach is said to be an opportunist. So such is not pessimist, it's not optimist, it's an opportunist. Okay. Because the person would act as though the thing has happened in order to calculate what he wouldn't have lost had it happened. It's very, very important You understand this? And please note that at this stage, we are using payoffs that are positive. More is better. We are talking about profit. If it was a loss and this person was the optimist, you would have gone for the lowest value. But now we can see that so far what we've done, we're talking about the highest value because these are sort of, the payoffs are positive. In other words, you want less of the payoff. You want more of the payoff. So this person would have regretted. So we have to now calculate the regret position for everybody. Okay. We have to calculate the opportunity lost. And the formula for calculating that regret is what you see on your screen. What is the regret? The value of the regret is given by this formula. Please write it down. What does that mean? The VJ star represents the highest value in the column. Remember, J is always column, I is always row. So the VJ star means that when you look at the numbers on the far right, far vertical, the highest value in that column, that is the VJ star. Now, since our columns are just two, we are going to have V1 star, and then we are also going to have V2 star. Who can tell me the value of the V1 star in this data set? What is the value of the V1 star? I mean, you all have the data by now. Michael.
100,000.
100. Very good. So you write that down. And what is the value of the V2 star? We are about to calculate a table known as the regret table. The regret table. What's the value of the V2 star? Let's get that down. The V1 star is 100. The V2 star is what? So normally you forget these things when you have not written the table. Should I go back to the table? Yasin.
Please, I've written the table, but I want to know what the VIJ stands for.
I said VJ. We are not looking at the VIJ yet. We are looking at the VJ star. I'll come to the VIJ. Kwesi? The VJ star for column 2. What is that?
Please, can you explain how you got the 100, the value for the higher? So
can I explain what?
How you got the 100?
Okay, the guy who got 100, can you explain it to me?
So, sir, you said that the VJ star are the highest value in the columns, and that for this problem set, we are having two columns, V1 star and then V2 star. And so V1 star is the column of the first, is the first column, is the values in the first column. And so what is the highest value within the first column? When we look at the first column, we have 50, 100, and 30. And so the highest value in that column, V1, is 100.
Okay. And you said it's not the Z now, right?
You're not finding VJ star.
Doc.
I'm only finding VJ star. That's what I'm asking about. I'm not finding anything else for now. It's only the VJ star I wanted you to find. I'll come to the VIJ. Yes, let's go to Dana Kwame.
So that's the 30,000. So
do you have the table now?
Yes, sir, I have the table.
Do you all have the table now?
Yes, sir.
Yes,
Because if you don't have the table, you come and ask questions like, how did you get that? How did you get that? Okay. So the V2 star, because it's column 2, is going to be the 30. So we now know the The highest number. Remember, the star means they are the highest numbers in that column. Write it down. That's what the star means. It means that they are the highest numbers. So when I look at the column 1, the highest number there is 100. Column 2, the highest number there is 30. Check a table. Now, according to the formula, we are supposed to create the regret. So you take the highest number minus the value in that column. So if I'm actually calculating the regret here, I will have to take the highest number, which is 100, minus the payoff in that section there. What is that? What is the payoff for apartment D1? That's it.
D1 is 30,000.
So what to be the regret there?
70,000.
Exactly. So the regret here is going to be 70. What to be the regret in the next one down here? Kwame. You can tell us the regret in the next one. But that same column. Yasin.
Please, 140.
Sorry?
140.
No. Remember, you are taking the number here, okay? You're taking the V1 star, which we know is 100, okay? And then you are subtracting the number that is the payoff here from it. So we have to use that same number for that column.
I feel like I don't understand when you say.
It's because I'm actually not showing the table to all of you. Laurentia.
And I have the table in front of me.
So from what you're saying, it will be 0. There will be no regret.
Explain to them why that is so.
So because the V1 is the highest value, the V1 star is the highest value, you mentioned that we would subtract the payoff within that column from the V1, which is the highest value. And the payoff within that's P21, that one was 100. So 100 minus 100 is 0.
That's it.
Then, Doc, please, if that's the case, then the 70 for
Yes,
D1 will not be 70, then it should be 50.
yes, it's 50.
Okay. So now, I mean, you have the numbers there. So it's good you have recognized that. So this value here will be 100 minus 50. And that is 50. What is the value in the third one? What is the payoff there? What is the payoff for the third one?
30.
So what will be the regrets?
So,
Kwame,
so
Kwame, your hand has been up 33 times. You are not talking. Can somebody lower his hand?
I tried to unmute.
Lower your hand. You lower your hand. Don't worry. Lower your hand. Yes, Daisy. Daisy, your hand is also up.
Yes, hello. Yes, please, I have a question. Please, I wanted to just find out, how are you solving for the payout? I'm not sure I heard that part. So can you please kindly take that again?
Payout. I am not
Okay,
solving
how
for
did you
payout.
get it?
How did I get
How
what?
The payout.
But the payout is the table I told you should all write down. Did you write the table down?
Yes, please, I wrote it down.
The
But
numbers that you have
what
are
you have
the payout.
written. Okay. Okay, what you have written, you've written 100 minus 100 for the second, for D2. And for D1, you've gotten 100 minus 50. Where are you getting the 100 from, please?
Okay, can somebody explain it to this girl?
He told us to ignore the zeros.
No, explain the thing to her. Don't say you told her to ignore. Explain the thing well like a teacher to the girl. She wants to know how we are finding the numbers.
Doc, please let me explain.
No.
Go ahead,
So
Yasin.
we said that if we want to find regrets, regrets is essentially the highest VG minus VIG. And VG stands for the highest value in that column. And so we have two columns, which was the good economic condition and then the poor economic condition. So that's how come we have V1 and V2, where V1 stands for the good economic condition and then V2 stands for the poor economic condition. So if you take your first column, which is V1, we are saying that what's the highest value in V1, and that is 100 because we had 50, 100, 30. So 100 is the highest value there. If you take poor economic condition, what's the highest value over there is 30 because we have 30, negative 40, and 10. So that's how come we are getting the 100 there. I don't
Tell
know
you
if it's
something. The problem is not they don't understand. They don't have this table in front of them. And because they don't have this table in front of them, they are struggling to see where I'm getting the numbers from. That's all. I can promise you that. I've done this thing for 14 years, and I know when people are not connecting the table, if I start connecting the table right now, they'll get it because they see the table. But the idea thing is that they are supposed to write the table in front of them and connect it to the table. Okay, so let me just go back to all of it. Sam.
I think the lady, what she was asking, how are you calculating payout? So I think the answer to her is that we are not calculating, but the payout have been listed there, and we need to let her know what is the payout. So
She says she has
the
this
payout.
table. Listen, she has this table. This table with 50, with 100, with 30, with negative 40, with that. She says she has it. And that is a payout. So it's not a matter of you have to tell her what the payout is. Because before a person writes the payout, before the person writes the table, the person should know what the table stands for. Because that's what we've been talking about all this while. So for me, if you tell me that, oh, I've written the table, but I don't know what the payout is about. I don't know what the payoff is about. I don't know what the profit is about. It means that the person didn't write the table, or the person wrote the table without understanding what the table is about.
So I think she didn't know that those things written there, the values written there, are what we call the payout. So that's why the
Let's move on.
confusion
So
is.
the highest value in this column is 100. That is the V1 star. The highest value in this second column is 30. That is the V2 star. Therefore, if you want to find the regrets for this first one, you have to find the regret for this. The regret for this is going to be this 100 minus the 50. That will give you 50. The second regret in that column for this 100 here, the second regret there is going to be this same 100, the highest value, minus this. That will give you 100, 0. The third regret will be for this 30, is going to be this 100 minus this 30, which will give you 70. Yeah. The third, the next column, you want to find the regret for this number. That will be the highest value in that column minus the number. So it will be 30 minus 30. That will give you 0. To find the regret for this negative 40, it is the highest value, which is 30 minus the negative 40. So that will be 30 minus negative 40, which will be 30 plus 40, which will be 70. And to find the last one here, you take that same 30 minus the 10, and therefore the regret value will be 20. Who doesn't still understand? Actually, I wanted you all to find the regrets. But the reason why some of you can't capture is because you don't have these numbers in front of you to see exactly what I'm doing. So the V1 star is this. If we had a third column, we would have had V3 stars. If we had a fourth column, we would have had V4 star. If we had a fifth column, we would have had V5 star. So that is it. You got to know that the stars are the highest value in the column, not in the rows, in the column. So now you have calculated the regret, and that is known as a regret table. What was originally there is the payoff table. The payoff are the values of the 50, the 100, the 30, the 30, the negative 40, and the 10. These are the payoffs. But from that, for each column, you got to identify the highest value there. And then you subtract everything one by one from that highest value only in that column. When you come to the next column, you pick the highest value there and subtract everything in that element from the highest value. So to be the highest value minus the value, the highest value minus the next value, the highest value minus the next value, until that column is exhausted. Then you go to the last column, and again and again and again. Once you've done this, the 50, the 0, the 70, the 0, there will always be a 0 in one of the columns. Who can tell me why there will always be a 0 in one of the columns? There will always be a 0 in one of the columns. Why? Benjamin.
Doc, because we always subtract the highest from the same value, or we do the subtraction of one value of from the same.
Your explanation is not precise. I know you know what you're saying, but
so Doc,
if you are teaching somebody and you say that, let Grace explain it. Let me see.
Okay, Doc. So it's because the highest value is picked from the same column. So you end up working with that same value. So it gives you a 0.
Yeah. The highest value is one of the elements. So when you subtract that highest value from its element, or you subtract the element from its highest value, you get a 0. So the highest value is one of them. It's one of the, the payoffs itself. So if you select the highest payoff, then if you take the difference, it's 0. So when you work it out and you don't get 0 in the rest, it means that there's something wrong. That's what it means. It means there's something wrong. Okay. Once you have gotten your data, your regret table, the next is to create a column known as the maximum regret. Take note, the maximum regret. Remember, the approach we are using is known as minimax regret. Minimax regret. That's the approach, minimax regret approach. And this is also known as the opportunistic approach, the minimax regret. Now, you see, at the word in minimax, there is the latter part is the max, is the max. So now you have to find the maximum regret. So when you go to apartment building, you select the maximum regret there. Between 50 and 0, which one is the maximum regret? That's what you pick. Between 0 and 70, which one is the maximum regret? That's what you pick. So who can tell me the maximum regret for all of them? Evans. Yasin.
So it is 50, 70, 70.
Okay. So that becomes the maximum regret. Then the last part is the minimum regret. In fact, that's what we call minimax regret. In other words, is a minimum of those maximum regrets you have selected. And what would that be? That's it.
50.
That would be 50. Therefore, based on the minimax regret approach, which decision are we going to select? Based on the minimax regret approach, which decision are you going to take, Deborah?
Apartment.
Okay. So far, looking at the first approach, what did we select? The maximax approach, what did we select?
We selected D2, office building.
The second one, what did you select?
Down, we selected D1, apartment building.
And now, with the minimax regret approach, so which alternative is winning so far using the three approaches? Susie.
The apartment.
Please, I'm not answering a question. I want to ask how we got the maximum regret side, the 50, 70, 70.
Yes,
Are we comparing? Okay.
Susie, please, can you come again? You want to know how we are getting there?
50, 70, 70. Are we comparing both the regrets for the good economic condition and the poor economic condition, and you choose the maximum, or we are comparing the column?
So before we did a regret table where we had 50, 0, 70, and on the next column we had 0, 70, 20. So for each line, you want to pick the highest regret. So
Okay.
for
Okay.
apartments building, we have 50 as the first regret and 0 as the
Okay. I
the
understand.
second regret. Okay.
All right. Thank you.
So the minimax regret approach uses the regret table. So far, apartment building has taken 2. Office building has taken 1. Warehouse has taken nothing. But it doesn't mean that apartment is the winner. You have to use all the approaches, and the one that has the maximum selected from all the approaches, that is the one that you would decide using. So we're going to go to another approach, and this is known as the expected value approach. Write it down in your notes because there are a couple of formula that you'll be writing. The expected value approach. Now remember, the minimax approach uses the payoff from the table. Sorry, the maximax and the maximum. But the minimax regret approach uses the regret table, not the payoff table. The regret table. So know the difference between the payoff table and the regret table. Remember also that if you calculate the regret and you have one wrong, it can affect your entire result. So you have to calculate the regret table very well. Now, we are going to go and look at the expected value approach. You see, the expected value approach uses something that we have not used throughout. And this is it. It uses something we call probability. Probability. By the way, all these while, no probabilities of occurrence was assigned to the state of nature. We have a state of nature, but we've not even used it. Because the state of nature is a condition that is outside the control of the management. And we need to know, the decision maker needs to know a lot about the future state of nature. Because you don't just invest, you don't just do things. You got to know the future, whether what I'm investing is going to help me. So you can hire an economic forecaster to forecast that. And there's a criteria for doing that. The economic forecaster can come out with probability that the economic condition is going to be poor, or the probability that the economic condition is going to be good. The moment you assign probabilities into the picture, now we are in a state known as the expected value approach. The expected value approach will require that we have a state of nature. By now, you all know that probability is between 0 and 1. And the sum of the probability is always equal to 1. So suppose that you have 3 different states of nature, and one of them has a probability of 0.3. The other has a probability of 0.5. The last one will have a probability of what? Deborah?
0.2.
0.2. So you got to know, and how you got a 0.2, we all know that you took the maximum of 1 and subtracted it from the other. But let me trick you. If you have a state of nature that is 4, and you are told that the first one has a probability of 0.1, the second one has a probability of 0.5, and the other two shares the probabilities, the third state of nature will have a probability of what? Yasin?
0.2.
0.2. So you got to know, these are some of the tricks you get in some of the questions that you need to be able to distill. The key point is, remember that probability add up to 1. So whatever is left is 1 minus what is there. Okay, so let's go back here. How do you find the expected value for each decision? For each decision, remember, anytime you are finding anything for each decision, it means that you're going to decide on it. So the expected value, write this formula down. The expected value of DI is simply taking the probability of the state of nature. I'm saying it from the back. You take the probability of the state of nature, and then you multiply that by that particular payoff, one by one, and you sum them. And that will give you the expected value for that particular decision. Write this formula there. Now let's go to the Kofi-Wayo situation. We are told here that Kofi-Wayo is able to estimate that 60% probability that good economic condition will prevail. That's all. That was the story. So if Kofi-Wayo has been able to estimate that 60% of the time economic conditions will be good, it means that how many percent of the time economic condition will be bad? You deduce that. Bennett.
40%.
40%. So you now know that a state of nature, let me just go back to the table. Okay. You now know, okay. You now know that the state of nature, the probability for the state of nature 1 is going to be 0.6. And the probability for state of nature 2 is 0.4. So you know that. Now we are going to calculate the expected value for decision alternative 1. That is apartment. How do we do that? As we said, you would take the probability and multiply it by the payoff, plus the next probability, multiply by the next payoff, plus the next probability, multiply by the next payoff, until you finish, and then you add them all back. So it's going to be 0.6 times 50 plus 0.4 times 30. Then you calculate that, you put it down. I want you to do that for all the 3 and tell me the answers for each one of them. When you finish, you raise your hand. For all 3. Raise your hand when you are finished. So far, I see only one person finished. Okay, so let me start with Daisy.
Okay, so for the first one, I got 42. For the second, sorry, please, can you hear me?
Loud and clear.
Okay. For the second one, I got 44. And for the last one, I got 22.
Good. Mayor, did you get the same thing?
Yes, I had the same thing, 42, 44, and 22.
Very good. So that's what you should get. 42, 44, 22. So based on this expected value approach, please remember it's also known as expected value without perfect information. Based on this expected value approach, which is also known as expected value without perfect information, which decision alternative will you go for? Which decision alternative will you go for? Which one should we select? Yasin.
Office building.
Why?
Because the expected value is 44, which is the highest out of all the three.
Good. So the word value means you want more. And then since that one has more than the rest, office building is the winner. So at this case, you can see that by taking the 4 approaches, you are able to detect that office and apartment building are really winning. But we don't end there. There's one more thing we got to do before we look at the other alternatives. It is a fact that what we just found is known as the expected value without perfect information. Without perfect information. Which means that there is expected value. Who can tell me? There's expected value PI. What is that? Yasin.
Expected value with perfect information.
With perfect information. But even more interestingly is that there is expected value of perfect information. Guys, pay attention before it start getting complex to some of you. There's expected value of perfect information. What is that? The information that we have here, that 60% of the time economic condition was going to be good, and 40% of the time economic condition was going to be bad. That information that we have is not perfect. We have used it, but we called it, if you can remember, the name we gave to it is expected value without perfect information. So even though we used it to do our calculation and we selected a 44, the information is not perfect. So you can buy perfect information. And what we are about to do is that if you are going to buy perfect information, you wouldn't want to buy perfect information that will give you less than the value you are going to use the information for. Let me repeat. You cannot get a perfect information. You won't pay more than what that perfect information can give you. You won't pay. You won't pay for that. But you can buy for more information about a future state of affairs. But you won't pay more for this information than what you will gain from it. So the information has some maximum limit. The value, listen here, of the information can be calculated as an expected value. The value of the information. So this is a one-time information. You want to pay. Okay. Normally, those who don't pay attention in class, they are the ones who will always interrupt. And it always happens. Then they will say they are sorry. But if you are really paying attention, you're taking note, normally they don't interrupt. Perfect information. You are conscious about the information, but you also want to get enough value from it. The money you part to get that perfect information is what is known as the expected value of perfect information. That is the money. How do you find that? Well, for your information, the expected value of perfect information is given by first this. So the EVP1, which is the expected value of perfect information, is given by the expected value with perfect information minus the expected value without perfect information, the absolute value of that. So the expected value with perfect information minus the expected value without perfect information. We already know the expected value without perfect information. It is actually the value we got from the expected value approach, which was what? What was the value we got using the expected value approach? Yasin.
44.
So we got this value here to be 44. Now, to get expected value of perfect information, we need to get that second one, the first one here. And the formula for getting the expected value with perfect information is simple. You are only taking the VJ star and multiplying each one by the probability of the state of nature, J, and summing it. This is expected value with perfect information. Write it down. So each VJ star, each column, multiplied by its respective probability, summing it will give you the expected value with perfect information. So let's start. What was the VJ star for the first column? Yes, I've seen.
100.
100. So we are going to take 100 multiplied by the first column probability. What is that?
0.6.
0.6. Then plus the next number, which is what?
30.
30 times what?
0.4.
So this is it. Remember, you're not using this to make a decision. You only make a decision whenever you are dealing with each separate decision alternative, each DI. But this one is not DI, it's for everything. That should give you a value of 28, correct?
It's 72.
It's 72. Sorry. It's 72. That should give you a value of 72. Now, that 72 will be here. And so that one is only helping you to calculate the EVPI. So now that you got that 72, you subtract it from the 44. That's 44 from it. And what do you get?
28.
28.
Yeah, so that's what I had in mind. So the 28, what is that? What is the meaning of that 28? Who can tell us? What does the 28 here mean? Yasin.
That is how much it will cost you to buy perfect information.
Yeah. And that is how much it's going to cost you to buy the perfect information. But that value is also something, pal. That is how much you are willing to lose. Watch another word. Put it down there for one day. That is how much you are willing to lose to get perfect information. Now, watch another phrase. That is how much you are willing to lose for your opportunity. That is how much you are willing to lose for your opportunity. So it's more or less your expected opportunity loss. The same way it is your expected value of perfect information. Those phrases I just used are very. That's it. Now we are going to go back to use the next approach to determine the decision alternative. Yasin.
Yeah, please, I got the other interpretations, but I feel like I also heard you say it is also the opportunity cost. Am I wrong?
Is the what? Opportunity cost.
Yeah, did you mention opportunity
Yeah,
cost?
I indicated that it is also the expected opportunity loss.
Okay.
The expected value of perfect information. You indicated that it is how much you are willing to pay for perfect information, which means it's also the same as how much you are willing to lose for perfect information, isn't it?
Yes.
Which means it's also how much you are willing to part to gain an opportunity, or to lose to gain an opportunity. And that is why it's also the expected opportunity loss. Because the next topic we are going to use criteria we're going to use to determine all of this is known as expected opportunity loss approach. The expected opportunity loss. Now that is the last approach we are going to be using. Yes, go ahead.
Please, just so like we're on the same page, it means before you make a decision, you first have to go through all the stages we've gone through, right?
Absolutely. Absolutely. You got to go through all of these approaches before you can come out with a decision you want to take. All of them in real life. Now, some few minutes ago, I indicated that the expected value of perfect information is also the expected opportunity loss. Do you remember? So let's look at the expected opportunity loss. Everybody, please write this formula down. Write the EOL formula. You can see that the formula is for each decision alternative. Anytime you have the DI, it means you're going to use it to make a decision, unlike the EVPI that we did. So the expected opportunity loss, remember that the expected value approach, if you can remember, it was using the probability of the state of nature and multiplying it by each payoff and summing them, if you can remember. That was called the EVWPI or the EV, simply. Okay. But now we have the expected opportunity loss. So it's not a value, but it's a cost, it's a loss. And this is not using the payoff. It's the same thing as the previous, but it's not using the payoff. It's using the regret table. So you take each probability of the state of nature, multiply it by the regret value. You take each one, multiply it by the regret value. And then you calculate it for each of the DI. Now, to be able to do this, it means that you need to remember your regret value. Okay, so these are the regrets. So I'm going to calculate the expected opportunity loss for D1. To do that, the EOL for D1, first you need the state of nature and multiply it by this value, the 50. Then you need the next state of nature and multiply it by the next value. Well, this is the state of nature, 0.6. And this is the other state of nature, 0.6. So if I want to calculate for apartment building, I will take the 0.6, multiply it by the 50, plus take the 0.4 and multiply it by 0. That will give you the expected opportunity loss for D1. Do the same for office building, D2. Do the same for warehouse, D3. When you're done, everybody raise your hand. Those who are done. So let's go to, let me see whether there are some new names. Bennett.
Yes, please. So the expected opportunity loss for D1 is 30, that for D2 is 28, and for D3 is 50.
So if you have to make a decision, which one will you use to decide?
D2.
Why?
Because that is the lowest opportunity loss.
Okay, very good. So using this approach, how many has warehouse 1? How many has office building 1? And how many has apartment 1? Can anybody tell us? Anybody? Yes, I see.
Apartment building has 1, 2, no 3. Office building is 2, and warehouse has 1, 0.
Yeah, Deborah.
Office has 3, apartment has 2, and warehouse has 0.
Before this EOL, they were at par. They all had 2, 2. And this EOL indicated who won?
Office building.
Office, which then means that office has added 1 more to the 2. And so, but there's something that you can see here. You can see that the value that you had here, okay, look at this value, 28. One of them was 28. What does this 28, which was the lowest opportunity loss, what does that remind you of? We're coming to draw some connections. What does that remind you of? Yes.
How much you are willing to pay for perfect information.
So what does that mean?
It means that's how much you are willing to lose.
I know. But what does this answer tell you about what we have already calculated?
It means that you don't want to lose more than you are paying for the information.
You're actually interpreting the thing, but I want a connection. Let me see. Benjamin.
That means they are equal.
What is equal?
EPVI is equal to EOL.
That's what it means. It means that anytime you want to know whether your EVPI, the expected value of perfect information you just calculated, anytime you want to know whether you are right, juxtapose that against the expected opportunity loss, the answer you had. They should give you the same answer. That's what it means. But there's also one more thing. Okay, where is that? Another thing is, so the expected value approach and the EOL all will always lead to the same conclusion. So you can see that we were at par 2-2 for apartment and then office until we calculated the EOL, the expected opportunity loss approach. And then it made office building have 3. And the decision it gave was office building. The same decision expected value approach gave us. So anytime you use the expected value approach and you get a decision and you use the EOL, expected opportunity loss, and you get a different decision, you should know that there's something wrong. Another thing, both approaches will use probabilities. One will use probabilities against what? Against what table? And the other will use probabilities against what table? Yasin?
One uses it against the regret table, and the other one uses it against the payout table.
Yeah, that's it. As a decision maker, it's your job to make a decision, okay, that is based on calculated facts, not guesses. I have this one here. I think in the slide I posted in the group page, you will notice that this one is also there. But I think I don't have the exact table, but you guys have the table that I've given you. It is about some questions, and you are supposed to use that to look at. This was an exam question, actually. Okay. So this was determine the best decision using the minimax and the maximum approaches. Actually, it's maximax and maximum approaches. Determine the best decision for the publisher using the minimum regret approach. Suppose the BTEA now has probabilities of the state of nature. What is the best decision under the expected opportunity loss approach? And that one is the one we just did. Find the expected value of perfect information and compare your results with C. Again, that should be something you should easily be able to do. Understand next week is in person, isn't it?
Yes, sir. It's in person.
By the way, any questions so far? Any question?